Every day, we interact with solids, liquids, and gases. But the fourth state of matter, plasma, is in fact the most common and makes up most of the universe. Plasma is a highly ionized gas of low density, induced with enough energy to cause a reaction that separates electrons from atoms and molecules, making them into ions. The high energy allows both electrons and ions to coexist in a cloud of particles. When we look at the sky, we witness plasma in each star in the universe. In the Sun, nuclear fusion releases a large amount of energy that separates electrons from hydrogen and helium molecules, which in turn produces a large mass of plasma gas. This reaction also produces energy in the form of visible light, radiation, and subatomic particles. But almost 90% of emissions from the Sun are actually radio waves and microwaves. Hence, stars are nothing more than a large plasma mass which emits radio and microwaves. Conversely, one can attain plasma from microwaves and matter through a controlled reaction using radio waves or microwaves to ionize an atom and gasify it into a plasma state. Unlike other plasma gasification processes in existence for some time, the ABA process produces a highly efficient reaction because it uses microwave induction, allowing matter to completely absorb the radiation. The moment an energized point is saturated, the microwave is naturally diverted to the next point to support a chain reaction. Any organic material can be gasified into plasma with the ABA process. When the material is microwaved, only carbon atoms are affected. Electrons are released, and when the atoms are destabilized, the temperature rises. Bonds with hydrogen atoms are broken and get recombined with superheated water to create hydrogen, carbon monoxide, and large-chain hydrocarbons. The hydrogen and carbon monoxide is called syngas or synthetic gas, which is the basic building block of the petrochemical industry. The ABA reactor is capable of efficiently decomposing organic matter at the molecular level to generate a series of products that can be exploited on a large number of secondary processes. The resulting gases are ideal for the generation of electricity through gas turbines before being used in a later stage. Through a Fischer-Tropsch secondary process, the gas can be transformed into products such as diesel, gasoline, and kerosene. All organic materials can be used as feedstock, making the ABA reactor the ideal application to dispose of most municipal, medical, agricultural, and industrial waste. Unlike other gasification technologies, the ABA process will not react violently with silicates, salts, metals, nor soils. These materials become a small amount of residual slag that can have numerous industrial applications, so in fact, nothing is wasted. Configurations and process components of the ABA reactor are flexible enough to adapt to municipal, industrial, or agricultural applications. The ABA reactor is an ideal vehicle for waste management in agricultural units, where one can convert organic waste to produce biodiesel as well as ammonium sulfate. These biofertilizers are returned to the ground to form a completely biosustainable agriculture that no other process can currently offer worldwide. In power generation applications, the synthetic gas produced is piped into gas turbines at an average of 33,000 BTUs per pound of waste. For a reactor of 120 metric tons per day, this means a generation of over 17 megawatts per hour. The ABA process itself takes up only around 2 megawatts per hour, leaving an excess of almost 87% of energy that can be internally used or sold to the network, making it one of the most efficient in the market. Waste materials do not need to be pre-treated or finely crushed, do not require the separation of metals or soils, can contain oils and other petroleum-based derivatives, and can include high levels of humidity, such as those found in feedstocks from sugarcane bagasse or paper pulp waste. With efficiency above any other plasma generating technology in the market, operations yielding zero emissions, the ability to leverage or use virtually any type of waste as feedstock, and applications in almost any branch of the industry. The patented ABA process for the gasification of organic or carbonic materials via plasma is now a key element for the solution to a sustainable future.